All right, before we do problem number 4, you guys first need to recall the quadratic formula, which says that x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So in this problem, a is equal to 2, b is equal to negative 2, c is equal to negative 1, and this x here is actually the sine of theta, because normally it's going to be written ax squared plus bx plus c equals 0 for your quadratic equation before you use it. So in our case, the x is represented by sine theta. So when we go to substitute in, what we get then is that the sine of theta is equal to the opposite of b, so that's 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a times c, all over 2 times a. So then simplifying this, we got sine of theta is equal to 2 plus or minus the square root of negative 2 squared is 4, and then plus, because we've got negative 4 times 2 times negative 1, that's a positive 8, all over 4. So that equals 2 plus or minus the square root of 12 divided by 4. Now you could go ahead and simplify this, but we're really just interested in getting a decimal out on our calculators. So we need to do it when we add. The square root of 12, and we need to find out what sine of theta is equal to when we subtract the square root of 12. So on your calculator, if you were to press 2 plus the square root of 12, close parentheses, and then press enter, and then divide by 4, you should get 1.366. Okay. Then what you're going to do is you're going to hit second sign to get the sign to the minus 1, and then I want you to hit second answer so that it'll pull in all of the decimals for you. Okay. And when you do that, though, you're going to get no solutions on that side because sine was over 1. Now over here, when you do sine theta equals 2 minus root 12 over 4, when you press 2 minus square root 12, press enter, and then divide by 4, you're going to get negative 0.366. So now, when you do it, you're going to do the same thing. You're going to do second sign, and then second answer, so that you don't have to pull in all of the decimals. We're going to find out that theta is equal to negative 21.5 degrees. All right, so the first thing to note is that negative 21 is not between 0 and 360. So we're going to have to think about this. And so then what happens is negative 21.5 would be down here in quadrant 4. But we want to know the angle in standard position. So what you're going to do is you are going to take 360 and you're going to subtract 21.5. And when you do that, you get 338.5. So our first answer is going to be 338.5. And then to get the second answer, we have to think about where else could sine have been a negative 0.366. Well, that would have happened in quadrant 3. And the reference angle is the same as what the calculator gave us. It's still going to be 21.5. And we don't worry about negatives with reference angles. So now I have to figure out what this angle is in standard position. So I go 90, 180, and then 21.5 more. So 180 plus 21.5 is going to equal 201.5. So that's my second angle. All right. So even though I have no solution over here, that's not the answer to the problem because this problem had two answers. So over here, while there weren't any answers on that side, there were answers here. So writing no solution is not a correct answer for your final answer to the problem. Okay, so moving on to problem number 5. We've got a Pythagorean theorem problem again. So we are going to start by saying that the cosine of theta is equal to the opposite of b, so -1, plus or minus the square root of b squared minus 4ac all over 2 times a. So the cosine of theta is equal to -1 plus or minus the square root of 1 plus 4 all over 2. So the cosine of theta is equal to -1 plus or minus the square root of 5 divided by 2. So we have to do the two possible answers. Cosine theta equals -1 plus the square root of 5 over 2. And in a minute, we're going to have to do cosine theta equals -1 minus the square root of 5 over 2. So on your calculators, you would press -1 plus the square root of 5 divided by 2. -1 plus the square root of 5, hit enter, and then divide by 2. And when you do that, you get 0.61803. So then to find out what theta is, you're going to hit second cosine, second answer. And when you do that, you get 51.8 degrees. Okay. Now that is an angle between 0 and 360, so that is one of our answers. Now we have to stop and think, in what other quadrant could we have had a positive 61.803? Well, that would happen in quadrant 4. That's where else cosine is positive based on all students take classes. So the reference angle is 51.8, but that's not the angle in standard position. So to figure out what that is, we're going to do 360 minus 51.8. And when you do that, you get 308.2. So we got two answers out. Now this one over here, when you type in -1 minus root 5 divided by 2, you get cosine is equal to -1.618. Now, if you were to press second cosine, second enter at this point, you would get an error because this is outside of the range -1 to 1. So over here, we're not going to get answers. So our only answers were 51.8 and 308.2. So now we're going to do one more of these. We've got -3 cosine squared theta plus cosine theta plus 3 equals 0. So, cosine theta is equal to opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So cosine theta is equal to -1 plus or minus the square root of 1 plus 4 times 3 is 12 times 3 more is 36. Over -6. So cosine theta is equal to -1 plus or minus the square root of 37 over -6. So now we're going to have to do the two separate problems. Where is cosine theta equal to -1 plus the square root of 37 divided by -6? Well, when you punch that in on your calculator, you get -0.847. And so then we're going to take the arc cosine of our answer And you're going to find out that cosine is equal to 147.9. So that's in quadrant 2. And our angle here is 147.9. But that's not our reference angle. To find the reference angle, which is always between the x-axis and the terminal ray, we're going to subtract 180 minus 147.9, and we're going to find out that our reference angle is 32.1 degrees. So now where else could cosine be a negative value? Well, that happens in quadrant 3. And our reference angle is 32.1. So we place that into quadrant 3, and then we figure out the angle in standard position. So you go 90, 180 plus 32.1 more. And when you do that, we get 212.1 degrees. So these are 2 of our answers to this problem. Now we want to check and see if there are any more. So we're going to do cosine theta equals -1 minus root 37 over 6. So here cosine theta equals -1.18 approximately. That's outside of the range of -1 to 1, so we're not going to get any answers there. So remember, sine and cosine do need to be between -1 and 1, but tangent doesn't. So if you were doing a tangent problem, getting a result that's outside the range of -1 to 1, you don't automatically cross that off. And that is solving Trig equations, day 2.